You have stood at the edge of something before. A cliff, a diving board, the top of a staircase in the dark. That small hesitation before gravity takes over. Now imagine that edge is 400 million miles wide, and gravity does not just pull you down, it pulls you apart. This is the event horizon of a black hole, and there is no climbing back from it. A black hole is not a hole at all. It is a place where so much mass has collapsed into so small a space that nothing, not light, not time, not you, can escape its pull once you cross a certain line. Astronomers call that line the event horizon. Think of it as a one-way door with no handle on the other side. To understand how something like this forms, picture a star many times larger than our sun. For millions of years, it burns, holding itself up against its own enormous weight through nuclear fusion, the same process that powers every star in the sky. But fuel runs out, and when it does, the star can no longer fight its own gravity. It collapses all at once, in on itself. What is left behind is not a star anymore. It is a single point, packed with more mass than the sun, crushed into a space smaller than a city. The space around it warps so violently that nothing can climb back out. Picture yourself falling toward one, feet first, drifting through the dark in a spacesuit. At first, nothing feels wrong. Space is calm. Stars wheel slowly behind you. You could almost believe you are simply floating. But gravity does not pull evenly. Your feet are closer to the black hole than your head, so they are pulled harder, much harder. The difference stretches your body, slowly at first, then violently, until you are pulled into a long, thin strand of matter, no wider than a thread. Scientists actually call this spaghettification. It sounds almost funny. It is not. This is the part where most people imagine a dramatic countdown, some final cinematic moment. The truth is quieter and stranger. As you approach the event horizon, something happens to time itself. To someone watching you from a safe distance, you appear to slow down, slower, slower still. To them, you seem to freeze at the edge forever, your image stretching and dimming, never quite vanishing, fading into the dark like a photograph left out in the sun. But from your own perspective, inside your own falling body, time feels completely normal. You cross the horizon in an instant, feeling nothing unusual at all, even as the universe outside falls silent and dark behind you. Two truths, both real, depending on where you are standing. That is what a black hole does to the laws you thought were fixed. Here is where it gets stranger still. Once you cross the event horizon, you cannot avoid the center, no matter what you do. Every direction you turn, every path you choose, leads only one way: forward, down, toward the singularity, the impossibly small point where all the mass is crushed together, and where, as far as anyone can tell, the laws of physics simply stop making sense. No one has ever measured what happens at that point. The equations break down. Even Einstein's own theory, the one that predicted black holes in the first place, admits it cannot describe what waits there. It is one of the very few places in the universe where science runs out of words. Astronomers have never seen any of this happen up close. Not directly. Everything described here comes from equations tested again and again, but never witnessed firsthand. The closest anyone has come is a single, blurry orange ring, captured in 2019 by a network of telescopes spanning the entire planet, working together as one enormous eye just to catch a glimpse of the shadow a black hole casts against the light bending around it. That image took over a decade to build, and it is, to this day, the closest thing humanity has to a photograph of the edge of forever. That is the strange part. A reminder that the universe runs on rules far larger than the small, ordinary physics of a human life. Gravity does not care about your plans for tomorrow. Time does not move the same for everyone in the room. And somewhere out there, an object you cannot see, cannot photograph directly, cannot survive touching, is quietly bending the fabric of space around it, exactly as it has for millions of years, waiting for nothing and no one. And yet, the very forces that would tear a person apart at the edge of a black hole are the same forces holding galaxies together, shaping stars, keeping planets in their patient, circling orbits. At the center of our own galaxy, a black hole roughly 4 million times the mass of our sun sits quietly, and every star in the Milky Way, including our sun, orbits around it, the same way the moon orbits the Earth. Without it, the galaxy as we know it would not hold its shape at all. Destruction and order, born from the same law. You have stood at the edge of something before. Now you know what waits on the other side.